Very good afternoon. Myself Dr. Ruchi Gupta, Associate Professor, IT Department. Today we will discuss structural testing. As in my previous lecture, I have discussed the software testing basic concept and the type of testing in brief. So we have used a various type of software testing. So there are two type of testing have been used. One is a functional testing and another one is a structural testing. Functional testing is known as a black box testing and structural testing is called as white box testing. So today we will discuss a structural testing or white box testing in detail. So structural testing or white box testing, it is a complementary approach that is called structure or white box testing. So once we have to apply this structural testing or white box testing, so in this process we need some structure of the program or we need some internal code of the project. So it permits us to examine, because it permits us to examine the internal structure of the program. So we have to just analyze the program, we have to deduct some errors in the program and we have to check. If there are some error found in the program, then we have to rectify it. We have to first discover the errors and then we have to recover the program for the errors. So in the white box testing approach, designing test cases. So first of all, we have to design some test cases that have the knowledge about the internal structure of the software, and therefore the white box testing, that's why it is called a white box testing or structural testing, because we have to test the internal code of the software. It is called white box because it is open, the code is open for all. So various criteria of structural testings are available. Path testing, flow graph testing, DD testing, cyclomatic complexity, graph metric, mutation testing. These are some approaches of testing. Structural testing. So first of all, we have discussed about the path testing approach. So path testing strategy, it requires us to design some test cases such that all linear independent paths in the program are executed at least once. So this is the condition of the path testing, that all the linear independent paths in the program are executed at least once. And linear independent path, it can be determined in terms of CFG. So how we can identify the linear independent path? Once we have to generate the CFG of the program, then only we have to identify the linear independent path in the program. So this type of testing involves, first of all, we have to generate a set of path, will cover every branch in the program, and finding a set of test cases that will execute the path in the program. And basically two type of graph has to be designed. One is a control flow graph and another one is a DD graph. So DD graph is just an improved version of a CFG graph, because in this DD graph we have to just combine the sequence statement together and we start with decision. So decision to, it's a decision to decision graph. So first of all, we have discussed about the control flow graph. Control flow graph of the program, it can be analyzed using graphical representation as a flow graph. So we have just convert the program, a set of statement into the number of nodes and edges. The flow graph, it is a directed graph which nodes are either entire statement or the fragment of statement, and the edges, it represent the flow of control between the statements. Suppose if I and j are the nodes in the program graph, there is an edge from I to no or fragment corresponding to j, it can be executed immediately, the statement corresponding to node j. And the flow graph, it can be generated from code of any problem. These are some examples of control flow graph. Suppose if we have a sequence statement, then we have to convert it into CFG. If we have any condition like if then else, then we have to convert in the following form. This is the CFG for while loop, this is the CFG for repeated until loop, and this is for switch statement. These are some examples for creating the control flow graph of the given program. Suppose if we have two conditions, two sequence statement, then we have to convert it into the CFG. If we have this if else condition, then we have to convert if then this, execute else then, and then exit. Similarly, for the while statement, we have to start this condition, then execute this, repeat this process until it will terminate. So these are some CFG for sequence selection and for iteration type of constructs. Just we have take one example. This is a program to compute the GCD of any given number. We have just convert this program into CFG. This is our while statement. Then if statement, then if the condition is true, then execute this third as 4, 5, and then it executed 6. This is another example of swapping for the, we have just convert this program into CFG. Now we come on DD graph. So DD graph, first we have to convert the program into the CFG, then CFG is being converted into the DD graph. So flow graph representation is the first step of path testing, and the second step is DD graph from the flow graph. So DD, it is known as decision to decision path graph, in which we have just concentrate on the decision node, not on the sequence nodes. So the node of the flow graph which are sequence are combined into the single node. Because we have just concentrate on the decision node, so we have to just combine all sequence node together. Hence DT graph is a directed graph in which node are a sequence of statement and edges show the control flow. The DD graph path is used to find the independent path of the program, and the condition of this that it execute all the independent path at least one time. This is the condition for DD graph. So we have this program, we have just convert this program into DD graph and find out the total number of independent paths in the program. So first is AB, ABI, then ADI, ACDI, then ACEFI, then ACEGHI, and then ACEGI. So we have to count all the independent path in the program. So two method of coverage of the program. One is a statement coverage. So the criteria is each statement executed at least once during the testing. Means each and every edge is to be traversed at least one, so that we can say that the program is correct. A set of path executed during testing should include all the nodes, and all the nodes should be covered. Limitation is that does not require a decision to evaluate false. So we have just first we have to convert this graph into a DD graph. Then we have to select some test cases and apply these test cases to check that all the edges are traversed or not. So with these test cases, all the edges are traversed at least one. So we can say that is correct. Second option is a branch coverage or edge testing. So the criteria of branch coverage is each edge should be traversed at least once during testing. Each edge should be traversed at least once, and each decision must evaluate both true and false during testing. So we have just first convert this program into DD graph, then check, apply these test cases on this program and check this branch condition criteria or edge testing. Now we come on the complexity, cyclomatic complexity. So we can calculate the complexity of the program once we have to convert the program into a DD graph. So it is known as the structural complexity because it gives internal view of code. So for more complicated program, it is easy to determine the number of independent path of the program. So McCabe's cyclomatic complexity, it basically defines the total number of independent path in the program. So the McCabe's complexity metric provide a practical way of determining the complexity or to identify the linear independent path in the program. So these are three methods for calculation of this complexity. The first method define that if we have a control flow graph, then the complexity is equal to Vg is equal to E minus n plus 2p, where E is a total number of edges, n is a total number of nodes, and p is a number of connected components in the program. Now we apply the method 2. It is an alternate way of computing the complexity of a program from an inspection. It is Vg is equal to total number of bounded area plus 1. It means total number of closed loop plus 1 in the program, in the CFG. The next method is the cyclomatic complexity of the given program. It can be easily computed by total number of decision statement plus 1. So with this third method, we can also find out the complexity of any program without converting it into the CFG. So means we can say that by just seeing the program, we can calculate the complexity of the program. So say we have take this example. In this example, we have total number of edges 7, total number of nodes 6, connected component value is 1. So the value of this complexity is 3 with one method. Again with second method, here we have 2 number of closed loop. So we have, it is just 2 plus 3, 2 plus 1, 3. Again with the third method, we have just count the decision statement, first and second. So here the value will be 3. Now if we discuss about that how we can calculate the component value. So the role of P in the complexity calculation, Bg is equal to E minus n plus 2p. It is required to be understood correctly. We define a flow graph with unique entry and exit point. So all the nodes reachable from the entry and exit. So this definition would result in the flow graph have only one connected component. So one could have imaging a main program and two called subroutines A and B. This is suppose if we have one main program and two are the subordinate of A and B of the main program. So here the value of connected component is 3. So in this case, the total number of edges 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Total edges 13. Number of node 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and plus 2 into 3. So the value of this, the complexity of this program is 6. You can calculate the complexity of any program easily. This is the complexity of this program. We have generate 5. You can also calculate the complexity of this program. This is 4. Now mutation testing. So software is first tested by using an initial test cases which we have already tested. So initial test suites build up from the different white box strategies. This is also come under white box testing. So after some initial testing is being completed, then only we have done mutation testing. So mutation testing, it is a fault based testing. So idea behind this mutation testing is to make some few changes in a program at a time. So how we can perform this mutation testing? So each time the program is changed, every time your program will change, so that program will called a mutant program, muted program, and the changes are called mutant. So mutants are executed with some test data to determine that test data are capable for detecting the changes in original program and mutate the program. So one is a muted program. Then we have to test the full test suite of the program. If there exists one test case in the first in the test suite for which mutant give incorrect result, then the mutant is said to be dead. If mutant will it remain alive, means we have to generate these mutant if we got some incorrect result for that test case, so we can say it is a dead mutant, and we get some correct result for that test cases, then we can say it is a alive mutant. So even after all test cases have been exhausted, so test suite is enhanced to kill the mutant, and the process of generation and killing the mutant can be automated by predefining a set of primitive changes that can be applied to a program. So this is the whole process of mutation testing. This is our whole program or project. We have just these test, apply the test cases, new test cases will be generated. So if when we have to test any live mutant, if it is yes, then new test cases will be generated, and if it is not, then it is completed. And that on some test cases which give some incorrect result, then it is going on to the dead mutant category. So mutants that are caught by test are killed. So this is the process of mutation testing. A major disadvantage of this mutation testing is that it is computationally very expensive method, because a large number of possible mutants can be generated, as we have generated here for testing. So it should be used in conjunction of some testing tools which would run all the test cases automatically. Now we come on the performance testing. So performance is basically, it is a non-functional type of testing. It is carried out to check whether system needs to non-functional requirement, which is identified in the SRS document, like security requirement, reliability requirement, efficiency requirement. So we have to check all these requirements through the performance testing. So there are several type of testing are to be discussed here. Among them, 9 type of testings discussed below. So these are some testing like stress, volume, configuration, compatibility testing, regression testing, recovery, maintenance, documentation, usability. All testing has been come under the category of performance testing. So stress testing, it evaluates the system performance when the system is in stress for a short period of time. Means suppose if we have to give some illegal input conditions, so that stress the capability of the software, means at that time your software is in stress because we have to give some illegal or incorrect input to the software. So we have just checked the system also for some illegal values. Next is the volume testing. It is especially important to check whether the data structure, array, queues, stacks have been designed successfully, extraordinary situations or not. For example, a compiler might be tested to check whether the symbol table overflow when a very large program is compiled. Configuration testing, it is used to analyze system behavior in various hardware on software configuration. So we have just checked some hardware configuration, software configurations about the software. In the compatibility testing, this testing is required when the software interface with other systems. So we have to just check that our software is compatible with the environment or not. Compatibility aims to check whether the interface function perform required. For instance, if system need to communicate with a large database, retrieve information, so that time the compatibility testing is required to test the speed and accuracy of data retrieval. Then regression testing. This type of testing is required when the system is being tested is in upgradation. So once we have to apply the modification, or we can say once we have to go on to the maintenance phase, that time system requires some modification. So at that time we have to perform the regression testing. It means we can say the system being tested is an upgradation of an already existing system to fix some bugs or enhance the functionality or performance. Regression testing is the practice of running an old test suite after each change. So every time when we have to change in the software, we again apply the regression testing. Next is the recovery testing. So recovery testing tests the response of the system to the presence of some fault or some loss of power, devices, services, etc. Means if we want to recover our software due to some errors like loss of power, devices, loss of device, loss of services, etc. So in that time we will apply the recovery testing, and it is checked that system recover satisfactory or not. For example, the printer can be disconnected to check if the system hang. The power may be shut down to check the extent of data lost or corruption. The next testing is the maintenance testing. It diagnoses the program and other procedures that are required to be developed to help maintenance of the system. So once we have to go into the maintenance of the system, that time we work on some existing software and we have to apply the maintenance testing. Document testing is also required. It is checked that the required user manual, maintenance manual, technical manuals are to be done properly or not. It is to be maintained properly or not, because ultimately the user will use all these user manuals for using the software. So if the requirement specify the type of audience which are specific should be designed, there is a manual is checked for the compliance. Next testing is the usability testing, that concern about the checking of user interface to see if all the requirements are to be met or not. So during usability testing, the display screens, format, other aspects related to user interface, requirements are to be tested. So we have done all these testing in detail during the system testing. So this is all about our software testing. Now once we have done this system testing, then we have to go on to the next step of SDLC and the last phase of SDLC, that is maintenance phase. Thank you very much.